Hello everyone, in today's class we're going to look at forces on a submerged surface. Previously we looked on a vertical wall, forces due to a static fluid on a vertical wall, and then we looked at an inclined wall, the given angle theta, and we were asked to find the resultant force and where the resultant force is taking place, which is the center of pressure, and HP was the distance from center of pressure to the surface of the fluid. That was HP. Okay, this point was the center of pressure, which was slightly lower than the centroid, which was the average height. Okay, now we're gonna move on to unfamiliar, more like shapes we'll see in our daily lives. So for example, we'll look at this water reservoir. Let me move it a little bit into the middle of the page. So this water reservoir here, which will look something like this. Looks something like that, and at the side here, the inclined side, there's a submerged shape. We can assume it to be a window, which looks something like that, and that's the centroid of the submerged plane. And we're asked to find, which is right here, this is the centroid. We're asked to find the resultant force acting on the submerged plane and where the resultant's acting. Usually the resultant is acting slightly lower than the centroid, which is called the center of pressure. If we assume this to be a free surface which is open to the atmospheric pressure, and we measure the depth from the level of the fluid to the center of pressure, that is called HP. And from the centroid of the submerged surface to the surface of the fluid, that is called HC, which is similar to what we've done in the vertical wall and the inclined wall, pretty much the inclined wall. Okay, but the only difference is that the wall is not inclined all the way up to the surface of the fluid. The shape is kind of abnormal. So what we'll do to find LC and HP, we'll assume this inclined surface to continue all the way to the surface of the wall. So we'll assume this to continue all the way up to the surface of the fluid, and the angle is given. The angle theta of that inclined plane is given, and we need to find LC, which is the length from the centroid, which is the center of the submerged surface, to the level or the free surface of the fluid. So that's LC, and this here is LP. Okay, so just like the previous class, we're asked to find the resultant force and the depth where the resultant force is acting. Now we know that resultant force equals to the average pressure times the area. Okay, we already established that the average pressure is HC times the specific weight of the fluid. We'll assume the specific weight is water of this example here. So specific weight of water times the area, which is the area of the submerged surface where we're asked to find the resultant force. Okay, and that area, the dimensions of it, it's a rectangle, so you would say it's length times width. but there's certain dimensions that you need to know, because later on you need to find the moment of inertia to find LP. Okay, so let's not jump ahead of ourselves. The dimensions for the submerged surface, this here is called the base, okay, and that is called the height, H. Okay, so it's base times height. Now, HC in an inclined surface, as we've seen before, it's H divided by 2. That's H divided by H, which is H divided by 2. But with different shapes, it has a formula. So, actually, no, that's LC. That's LC. HC is basically, to find it, in order to find it, I'll show you how to get that. So you'll basically take LC, which is the length from the centroid of the shape to the level of the fluid, and you'll take HC and LC, right, with the angle given. So it looks something like that. This is HC, that's LC, which is unknown. That's the surface of the fluid, and that is the given angle. So sine, using geometry, sine theta equals HC, which is the depth from the centroid to the top level of the fluid, divided by LC. Therefore, LC equals HC divided by sine theta. Okay, and that's how you find LC. For the resultant force, the HC is given, the specific weight of water is given, and the dimensions of the submerged plane is given. So you basically found FR. Now, to find where the resultant force is happening, first thing you need to find LC, and the reason behind that is because you need to find LP, where the length of where the pressure, the resultant force is happening. So it's from the surface all the way down to where the pressure or the resultant force is happening, the center of pressure. Okay, so LP is given by an equation, which is LP equals LC plus IC, which is the moment of inertia, over LC over A. Now, the moment of inertia, it depends on the submerged surface. It could be a rectangle, it could be a circle, it could be a triangle. It's usually given. So in case of a rectangle, the moment of inertia will equal to B H cubed over 12. Okay. Now for a square, circle, triangle, it could be different, but that's the case for a rectangle. And the area again, which is base times height, and LC you found using geometry. Okay, now the reason you want LP is because the main point is to find the depth where the center of pressure is happening, which is HP. In order to find that, you need to know LP, which is the length from the center of pressure to the surface, and then you can use this triangle here to find HP. Okay, now, so if this is our HP, that's the LP that we found using this equation. Okay, and this is the surface of fluid. This is the angle of inclination, which is here, which is given. Now sine theta equals opposite, which is HP, over LP. Therefore, HP equals LP sine theta. And that's how you find the depth of center of pressure. In the next class, we'll go over a few examples. See you in the next class.